Hey everyone, my name's Trevor, and in this video we're going to expand on the save and load system created in a previous tutorial by setting up that system to be used across different scenes in Unity. We'll create a main menu scene where we can start a new game or continue from the previously saved game, which of course will transition us to our gameplay scene with either new game data or the loaded save data. And while we're going to use the save and load system created in a previous tutorial, I did try to structure this video in a way that will hopefully be helpful even if you already have your own save and load system and are just trying to figure out how to make it work with scene transitions. But obviously in that case, the relevancy of this tutorial completely depends on how your save and load system works compared to the one that we're going to use. And of course, like with any of my tutorials, everything that we're going to do can be found on GitHub, which I'll put a link to in the description of this video. So let's talk a bit about how this is going to work. First, I want to do a quick recap of the save and load system that we'll be starting with. The game's data is represented by a C# class called GameData, and we have a singleton class called the DataPersistenceManager, which acts as the brains for dealing with that game data. The DataPersistenceManager collects and keeps a list of references to all scripts in the scene that implement a custom interface called iDataPersistence, which indicates that the implementing script needs to persist data outside of the application. In the DataPersistence Manager, we already have a new game method, which sets our game data to a clean slate. We have a SaveGame method, which calls all scripts that implement the iDataPersistence interface to collect the most up-to-date data, serializes that data into JSON, and then writes that data to a file. And last, we have a LoadGame method, which reads the JSON data from that file, deserializes it back into the C# game data object, and then pushes that data to each script that implements the iDataPersistence interface so that they can initialize from it. Right now, we're simply loading data when the game starts in the DataPersistence Manager's start method, and then saving data when the game exits in the onApplicationExit method. So that's the save and load system that we'll be starting with, but now let's think about how this works when dealing with different scenes in Unity. In Unity, there are two types of scene loading, single and additive. In single scene loading, when a new scene is loaded, the previous scene is completely destroyed, which of course includes all of the game objects that were in that scene. However, in additive scene loading, the previous scene is not destroyed and instead is just added on alongside any other existing scenes. So for this tutorial, I want to clarify that we're only going to focus on single scene loading. With that said, if you're interested in additive scene loading and how that might work with a save and load system, feel free to leave a comment and let me know. If there's enough interest, I'll consider doing a separate video on that topic down the line. Anyways, let's say our game is broken into multiple different scenes and we're only worried about single scene loading. What we want to do is think of each scene as a clean slate that we can load data into when the scene loads. As for saving the game, we can do that whenever is appropriate for the game itself, but for this tutorial, we're going to save data anytime the scene is unloaded, so that data always persists automatically when we transition scenes. There are some Unity built-in events for this called sceneLoaded and sceneUnloaded that we can use to accomplish this by subscribing to those events in our DataPersistenceManager class. As mentioned though, when we transition to a new scene, everything in the previous scene will be destroyed. This of course includes the DataPersistence We can make the DataPersistence stick around through scene transitions using a Unity built-in method called DontDestroyOnLoad. But if we do that, and each scene is set up with its own data persistence manager for development reasons, we'll run into an issue where we end up with more than one data persistence manager in the scene, which will screw things up because of the singleton nature of how the data persistence manager works. To ensure that doesn't happen, each data persistence manager can check if the instance already exists in the scene before it initializes, and if one does exist, then the newest one can destroy itself so that we never have more than one of them in the scene at any given time. With that design, we can start up from any scene in the project, and the data persistence manager that we start with will be the one that sticks around with us until the application exits. And that's how it's going to work. Now let's jump into Unity and start implementing this. Starting off, we already have a gameplay scene called Sample Scene where there's a player that can run around and collect coins. We're saving and loading the specific coins that have been collected, the amount of times that the player has died, and also the player's position in the scene. This project is using TextMesh Pro, which can be installed through Unity's package manager, which we will use later as part of creating the main menu. And last, this project is also set up using Unity's new input system. It's not super important for this tutorial to be using the new menu input system, but just take note that if you're using Unity's default input system, the main menu navigation we're going to do later might look a little bit different. So starting off, since the Data Persistence Manager can potentially exist in multiple scenes, it would be convenient to turn that into a prefab just to make managing changes to it in the future a bit easier. Under the Manager's game object in the scene hierarchy, I'll click and drag the Data Persistence Manager game object into the prefabs folder of the project to make it a prefab. Now, if we want to do something, like for example turn encryption off, we'll be able to do that in any scene and then apply those changes to the prefab. Next, we'll create a new scene for the main menu. In the scenes directory of the project, we can right-click, create, and then select scene. We'll call this scene main menu and then double-click it to open it up. This main menu is going to be very simple with just two buttons, one to start a new game and another to continue a saved game. But first, we'll drag in the Data Persistence Manager prefab that we just created to add it to this scene. Then I'm going to change the background color of the camera just to make it a bit darker. Next, we'll create a new button by right-clicking in the scene hierarchy, going to UI, and then Button Text Mesh Pro, which will create a new button that we'll call Continue button. You'll also notice that this creates a canvas as well as an event system. Under the canvas for the UI scale mode, we're going to select Scale with Screen Size so that the menu items change with the screen size, and we'll just use a reference resolution of 1920 by 1080. As for the event system, we're going to come back and configure that in just a bit. We can center the button in the middle of the screen by clicking on the button and then in the rect transform, clicking on this square here, holding Alt and Shift on Windows, and selecting the center middle option. Then we'll make the button a bit bigger by giving it a width of 350 and a height of 100. And next, we can click on the child object to this button, which is the Text Mesh Pro text that's on the button, and we'll change the text to say continue in all caps, change the font size to 50 to make the text bigger, and we'll also bold it. And then back in the button component, we'll change the disabled color to be a bit darker, we'll make the selected color a brighter blue so it's clear which button we've selected, and we'll make the pressed color a slightly darker blue. And that looks pretty decent for a main menu button, so we'll duplicate that using Ctrl-D on Windows and then move the duplicated button to be a bit below the original one. We'll keep this bottom button as the Continue button, and I'm actually going to change the top button to be the New Game button. So we'll rename the game objects in the inspector, and then of course change the text on the top one to be New Game. And finally, let's hook these buttons up to our event system so that we can see how they look when we play the game. In this case, I always want the first selected button when these load up to be the New Game button, so we can drag the New Game button into the first selected slot of the event system. Now, this next part is going to be just a bit different depending on which input system you're using. I'm using Unity's new input system, so that's how we're going to set this up. We'll click on this Replace with Input System UI Input Module button, which is going to change this component. By default, it tries to use a built-in input action asset, but we already have one in the input folder of this project that we can just drag into that slot. We can see here that it automatically filled out the Move section for us, but the other one we need for this tutorial is the Submit section, which will indicate the input used to press one of the buttons. In the input action asset, I only have a couple of options here. You could add a Submit action if you'd like, but for this tutorial, I'm just going to use the player's jump action. And now, if we play this scene, we'll see that we can move back and forth between the New Game and Continue buttons as expected. And if we hit the Submit button, we'll see that it's trying to click those buttons as well, but of course nothing is happening yet because we haven't hooked them up to any code. So let's do that next. Under the scripts folder of the project, we'll create a folder called Main Menu, and then in there we'll create a new C# script, call it Main Menu, and then double click it to open it up in a code editor. We can get rid of these placeholder methods, and then we'll create two public void methods called onNewGameClicked and onContinueGameClicked. For right now, we'll just put some debug.log statements in here so that we can make sure that everything in Unity is hooked up correctly, and then we'll come back to implement these methods properly in just a bit. Back in Unity, under the canvas in the scene hierarchy, we're going to create a new empty game object and call it Main Menu. We'll make sure that the positional values are zeroed out, and then just for organizational purposes, we'll drag our buttons onto the main menu so that the buttons become children game objects. Then we can drag the main menu script onto the main menu game object to add it as a component. Next, for the new game button, we'll click on it and scroll down to this section here and click on the plus button to add an on-click listener. We can drag in our main menu game object to this slot here, and then in this dropdown, we'll select main menu and then the onNewGameClicked method that we just created. And of course, we'll do the same thing for the continue button, except we'll select the onContinueGameClicked method. And after that, if we play this again and actually press the buttons, we'll see some logging that indicates our main menu script is being called as expected. Now, before we fill out these methods, we should make a couple of modifications to our DataPersistence script to better deal with scene transitions. Back in Unity, we'll navigate to and open up the DataPersistence script that was built in a previous tutorial. As mentioned at the beginning of this video, instead of loading the game in the start method and then saving only in the onApplicationQuit method, we're going to add a couple of other lifecycle methods that will work a bit better for dealing with scene transitions. At the top of this script, we'll add a using statement for UnityEngine.SceneManagement. Then we'll create a new method called onSceneLoaded, which is going to take in a scene and a load scene mode, and we'll also create another new method called onSceneUnloaded, which is just going to take in a scene. Now, for these lifecycle methods to get called, we actually need to subscribe to them. It's really important here that we understand where the sceneLoaded event fits in the Unity lifecycle. Looking at the Unity documentation, we can see that onSceneLoaded is called after onEnable, but before start. This means that if we subscribe to that event in the start method, our onSceneLoaded method won't actually get called the first time that the game starts up. The recommended spot to subscribe to this event, as well as sceneUnloaded, is in onEnable. And likewise, we'll want to unsubscribe from the events in onDisable to keep things cleaned up. So let's do that real quick. We'll add an onEnable method and an onDisable method, and then subscribe to the events in onEnable and unsubscribe from them in onDisable, like so. Understanding where sceneLoaded fits in the Unity lifecycle is also important because since sceneLoaded will fire before our start method, anything in our start method may not be initialized when onSceneLoaded is called. In our case, we'll want to move the creation of our data handler to our awake method so that it exists when onSceneLoaded is called. Otherwise, we'll get an error when we try to load the game, since that requires that the data handler already be initialized. And we'll also move these other two lines out of our start method and into our onSceneLoaded method so that every time a scene is loaded, we reinitialize our list of data persistence objects and then load the game. And since there's nothing left in our start method, we'll just remove it. And last, we'll add a call to SaveGame in our onSceneUnloaded method so that data is saved every time the scene is unloaded. And keep in mind here that we're also going to keep the SaveGame call in onApplicationQuit, because if the user just exits out of the game, onSceneUnloaded actually isn't called, but onApplicationQuit is called. And also, just to really illustrate when these methods are getting called, let's add some debug.log statements to both the onSceneLoaded and onSceneUnloaded methods. And now with that logic in place, let's go back to our main menu script and fill out these two methods. When we click New Game, the first thing we want to do is initialize our game data by calling the NewGame method in the DataPersistenceManager. And next, we can simply load the gameplay scene, which will in turn save the game because of the onSceneUnloaded method we just implemented. And we'll also need to add a using statement for UnityEngine.SceneManagement. And before we continue, I want to take a moment to reiterate how this system will work when we create a new game. The NewGame method in our DataPersistence simply sets our game data variable to a clean slate. However, SaveGame needs to be called directly afterwards to actually persist that data outside of the application. When we transition scenes, onSceneUnloaded will get called, which will save the data. Hence, all we need to do from our main menu is call NewGame, and because of how we've set this up, our system will naturally persist that data outside of the application when we transition to the gameplay scene. And then when we want to continue the game, we just need to load the gameplay scene, and then the sceneLoaded event will fire, which will load whatever pre-existing data we have saved. One last thing I want to do here is disable all of the buttons in the menu when we click one of these options. This just ensures that when one of these buttons gets clicked, the player can't accidentally double-click an option or choose another option while the next scene loads asynchronously. With that said, with how we're using load scene async right now, I don't believe we'd actually run into that scenario, so it's up to you if you want to do this part or not, but I'm going to do it just to be safe. We'll add a using statement for UnityEngine.UI, and next we'll add serialized field button variables to the top of this script for the new game button and the continue game button. Then we'll create a disable all buttons method and then set the interactable value on both of these to false so that they can't be clicked again. Then we'll call that method to disable the buttons at the top of both of our onClick methods. And finally, back in Unity, be sure to drag in the buttons to the main menu script, and then we'll play this and see how things go. So right away we can see that onSceneLoaded was called when the game started up. If we select New Game, we'll see that it transitions us to the new scene, but if you take a look at the logging, you'll notice that the onSceneUnloaded logging that we added isn't being shown. This is because the Data Persistence Manager in our main menu scene is actually getting destroyed along with the rest of the main menu scene before the sceneUnloaded event actually fires. For this reason, among others, we'll want to make the Data Persistence Manager not get destroyed when we transition between scenes. And as mentioned in the beginning of this video, we'll use the Unity built-in method called DontDestroyOnLoad, which can be used to persist any game object we want between scenes. Back in the Data Persistence Manager script, in the awake method, we can call DontDestroyOnLoad and pass in the game object that this script is attached to so that this game object sticks around when we transition scenes. We'll also want to keep in mind though that for development reasons, the scene we transition to might also have a Data Persistence Manager in it. So when the Data Persistence Manager tries to initialize, but an instance has already been initialized, we'll destroy it and then return right away. And we'll also modify this logging statement to let ourselves know that the newest one was destroyed. Now back in Unity, we'll hit play and give this another try. So just like before, we see that the scene has been loaded, but now there's also this DontDestroyOnLoad section in the scene hierarchy, which if we expand it, we'll see the Data Persistence Manager there. Next, we'll hit New Game, which will load the gameplay scene, and this time we'll see that the onSceneUnloaded method was called like we want it to be. And if you remember towards the beginning of this video, our gameplay scene already had a Data Persistence Manager in it, so we also see that logging indicating that the new one was destroyed because the one from our main menu already existed. And just to confirm this, we can check the Manager's game object in which we won't see the Data Persistence Manager that was previously there. And finally, we see that onSceneLoaded was called for the gameplay scene, which is what loaded the initialized data. So now if I run around and collect some coins and then quit the game, which will save the data thanks to the onApplicationQuit method, and then play the game again, this time selecting continue, we'll start from where the game left off. So that's all working as expected, but there's still a few things that we need to polish up before we can call this done. First, if we delete our saved data file and then play the main menu scene, we're able to click the continue button, which right now results in starting a new game because of how the LoadGame method in the Data Persistence Manager is currently implemented. This made sense before we didn't have a main menu, but now that we do, it would be beneficial to change the LoadGame method in a way that forces us to start a new game first. Otherwise, as we expand onto this system, we could unintentionally call LoadGame in a spot where data hasn't been initialized yet and accidentally wipe out our saved data as a result. So in the LoadGame method, if data hasn't been initialized yet, we'll change this logging statement a bit, and instead of starting a new game here, we'll just return. With that change, this creates the possibility that our system might try to save the game before a new game is created, which means the data will be null and SaveGame will throw an error. As such, we should check if the game data is null at the top of the SaveGame method, and if it is, we'll just return so that the saving logic isn't reached. And while we're in this script, I'm going to get rid of the logging we previously added for onSceneLoaded and onSceneUnloaded, however you can keep it there if you'd like to. So that's all good, but this doesn't stop the player from actually hitting the continue button before a new game has been created. If we delete our data and then go back into play mode and hit the continue button now, we'll see that we're getting a bunch of those logging messages and warnings because we're trying to load and save data, but the data hasn't been initialized through creating a new game. And in this case, if we exit play mode and check where the data should be, we'll see that nothing has been persisted. To push the player into creating a new game first, we can simply disable the continue button when there isn't any game data. In the Data Persistence Manager class, we'll add a method called hasGameData in which we'll return whether or not the game data is null. Then in our main menu script, we can create a start method, and in there we'll call the Data Persistence Manager to check if it has data. If it doesn't have data, we'll disable the continue button by setting interactable to false. And now, if we play the game without having saved data, we can no longer select continue. But if we start a new game, exit play mode so the game saves, and then play the game again, we'll see that we can continue now because we do have saved data. And that's all working pretty well, but the last thing that I want to mention is that in development, it's likely that we'll want to play our other scenes directly and not have to go through the main menu every time. Right now, if we try to play our gameplay scene, we'll get a warning mentioning that DontDestroyOnLoad objects should be at the root level of the scene hierarchy. This is a really simple fix. We just need to drag the Data Persistence Manager game object into the top level of the scene hierarchy so that it's not parented by anything, and then when we replay the game, we'll no longer see that warning. As it's working right now, this works just fine if there's already saved data available when things start up, but if we delete our data and then try to start up, we're going to get the warnings we wrote indicating that a new game needs to be started before data can be loaded or saved. To make things easier for development, we're going to add a configuration to the Data Persistence Manager to create a new game in these situations where we might want to test the data persistence related stuff but don't want to go all the way through the main menu every single time. In the Data Persistence Manager, we'll add a new variable to the top called initializeData if null, and then default it to false. Then in our LoadGame method, we can check if that variable is true or not, along with if the data is null after we've tried the load data, and if it is, we'll create a new game here, kind of like how we were doing before. Then back in Unity, we can toggle this on or off depending on if we want data persistence or not without having to go through the main menu. So now if we check this and then start the game, we'll see that we don't get any warnings even though we didn't have any saved data. And if we stop the game and play it again, we'll see that the data is persisting just like before. And that's it. Thank you so much for watching. You might have noticed that we're missing a load game option from the main menu, which is a bit more involved and something I wanted to do a separate video for. And so the next tutorial will be on expanding this menu to have multiple save slots and to be able to select those from the main menu. So be sure to subscribe so you don't miss that, and if you like this video, please give it a thumbs up as well so more people see it. I also have a Discord server that's a good place to come by and ask questions, suggest a video topic, or just hang out and tell me about the game that you're creating. You can also follow me on Twitter or Instagram where I mostly post about the game that I'm creating. Anyways, thanks again for watching, and most of all, I hope this was helpful.